the part is principal and second part is analytic part, where it is defined for the function of complex variable, right? So here we will be expanding the given function f of z. What does z stand for? Z stands for x plus iy. What is this f of z? It is usually defined or denoted by w, where w is u of xy plus I times v of xy. So in the earlier question or the examples, we have seen how for the different regions we are going to expand the given function. See, expanding the given function for the given region, series should converge. I told you in the earlier class also that converging a particular series means it should exist. For its existence, it should be always considered as less than 1. The given region should be converted to always less than 1. Once that is completed, we can easily factorize the given factors, apply the appropriate binomial expansion as per the terms available, and then try to simplify or generalize the given expansion of the given function, right? So here the third question says expand sin z upon z minus pi about z is equal to pi using Lorentz series expansion. See, before this also, whenever we have such kind of term at z is equal to pi, if you try to put the value in the denominator, it is surely going to give you answer as 0, and it will be difficult for us to expand the given function. So what I do is I put the value or substitute the quantity z minus pi as u. So z is equal to u plus pi. That means pi plus u. So this sin z upon z minus pi will become sin of pi plus u upon u. Now as per the rule or sin of a plus b formula, the expansion of sin of pi plus u कैसे रहेगा? Sin a cos b plus cos a sin b. So ultimately it will be minus of sin u. So expansion of this sin of pi plus u, ये अपने को पता है sin of pi plus theta is minus sin theta. Another formula or the rule what is available with us is sin of pi plus theta will be equal to minus sin theta. So accordingly pi plus क्या है मेरे पास u है, तो वो क्या होगा pi plus u will be minus sin u. So this is the rule or this is the angle formula, factorization formula available. So accordingly, try to simplify and get the answer. So expansion is now minus sin u upon u. Keep minus 1 by u outside. What is the series expansion for sin u? It contains all the odd powers with alternate plus minus. So I have the first term as u minus u cube by 3 factorial plus u to the power 5 by 5 factorial minus u to the power 7 upon 7 factorial and so on. So accordingly, we will be having the terms in a similar fashion, right? So now multiply by 1 by u to all terms or the whole expression. So minus 1 by u into u, sorry, minus 1 by u into u will be minus 1. This minus of minus will become plus. U cube by u will become u square in the numerator. Denominator will have odd term factorial. Minus into plus will become minus. U to the power 5 upon u will become u to the power 4. This 5 factorial will remain as it is. Minus of minus will become plus. U to the power 7 upon u will become u to the power 6. And this will be 7 factorial, right? So appropriately. Now expansion is over. My purpose of substitution is also over. So I replace the value of u as z minus pi, because see, expansion was asked to be done about z equal to pi. That means about z minus pi equal to 0. So my expansion of the given function should contain the powers of z minus pi. So accordingly we simplify and get the answer. Any difficulty in this? I hope it is clear to all. Gaurav, Digmandar, Mohit, Mohit, you have joined from after so long. first lecture will not be very easy for you. If any difficulty you contact me later. ठीक है, अभी जो बता रहा हूं वो लिख लीजिए, सुन लीजिए बराबर. सक्षम, क्लियर बेटा? ठीक है. Yes, completed with the solution. Any doubt? Steps are clear. अर्नव, z माइनस पाई है, एक्सपेंशन एक्सपेक्ट कर रहे हैं वो z इक्वल टू पाई में, तो उसी को अपन सब्स्टिट्यूट कर देंगे एज अ u एंड देन सिंप्लीफाई. रिमेंबर दिस रिजल्ट, साइन ऑफ पाई प्लस थीटा इज माइनस साइन थीटा. ओके. नेक्स्ट, expand f of z is equal to z square plus 4z plus 3 raised to power minus
Sir,
1 by...
screen is not visible.
Screen is not visible. Is it okay now? अभी दिख रहा है क्या?
Visible, sir.
अभी दिख रहा है? Is it okay?
सर पहले दिख रहा था, अभी
No,
नहीं
sir.
दिख रहा.
अभी नहीं दिख रहा है? How many of you are still not able to see because it's showing that I am presenting? Is my voice clear or any interruption?
Clear, sir.
Clear. स्क्रीन दिख रहा है क्या अभी कि नहीं दिख रहा है अभी भी?
Both clear, sir.
Okay,
दिख
fine.
रहा है सर.
Okay. Please write down the next. Expand f of z is equal to z square plus 4z plus 3 to the power minus 1 by Lorentz series, which is valid for first region is 1 less than mod z less than 3. Second region, this kind we have dealt earlier, 0 less than mod of z plus 1 less than 2, mod z less than 1, mod z greater than 3. So f of z is this, raised to power minus 1 means 1 upon z square plus 4z plus 3. How to factorize this term? Z square plus 4z plus 3 will be factorized as z plus 1 into z plus 3. Now since it is the product, we try to resolve it with the help of the partial fraction. So I told you that whenever the factors are in the product, kindly take the subtraction or the addition and look for whatever term is remaining, divide by that. 2 बचेगा शायद, 3 minus 1 2, तो 2 से मैंने divide कर दिया. Otherwise you take this as a upon the first factor plus b upon the second factor and then simplify. ठीक है. अगर डिफिकल्टी जा रहा होगा तो a अपॉन प्लस b अपॉन करके दूसरा फैक्टर्स को करके you can find the value for a as well as b, but for time being you can go with what I am telling you. This will be simplified or resolved with the help of partial fraction as half of bracket 1 upon z plus 1 minus 1 upon z plus 3. So 1 upon 2 times z plus 1 minus 1 upon 2 times z plus 3. Now what is our first region? First region is 1 less than mod z less than 3. I told you that we have to split this into two parts. One of the part is 1 less than mod z, another part is mod z less than 3. 1 less than mod z में क्या करना पड़ेगा? Mod of 1 by z less than 1 divide by z on both sides. ठीक है. और mod z less than 3 में mod of z by 3 less than 1. Now you have factorized it with the help of, or you have resolved it with the help of the partial fraction. So it just take the term appropriately outside so that 1 by z is introduced in the first bracket. Take the term appropriately outside from the second factor so that the term z by 3 is introduced there. So z कॉमन निकालोगे तो 1 प्लस 1 बाई z होगा, 3 कॉमन निकालोगे तो 1 प्लस z बाई 3 होगा, and appropriately then raise it to the numerator with power -1 and expand it using the binomial expansion. I hope this is clear to everybody. कुछ बचा है? अभी दिख रहा है सभी को? Any doubt? Any clarification needed? Are you able to write simultaneously? Is it okay? Clear? So expansion of the terms. This 1 upon 2z is kept as it is. 1 plus 1 by z raised to power -1. Apply binomial expansion. -1 by 6 as it is. Raise this bracket to the power as -1 and then we apply binomial expansion. What is expansion for 1 plus x to the power -1? 1 plus x to the power -1 is 1 minus x plus x square minus x cube and so on. So this will become 1 minus 1 by z plus 1 upon z square minus 1 upon z cube and so on. 1 plus z by 3 raised to power -1 will become 1 minus z by 3 plus z square by 9 minus z cube by 27 and so on. See, in one of the bracket the term z or variable z appears in the denominator. In one of the bracket it appears in the numerator. So we cannot club them together. Only if there is any constant we can keep it or write it outside. Remaining terms will be written appropriately. We cannot collect the like terms looking at the coefficients or the variables because there is a difference in the position of the variables. So ये वाला ब्रैकेट मैंने पहले लिखा है -1/6 का, प्लस ये वाला ब्रैकेट में 1/2z से मल्टीप्लाई कर लिया है, मल्टीप्लाइड एवरी टर्म बाय 1/2z. So it becomes 1/2z minus 1/2z square plus 1/2z cube and so on. फोर्थ टर्म क्या आएगा? -1/2z to the power 4 and so on. Clear? It is the same. These two terms are same. This and this is same. Now I have taken 1 by -1/6 outside and remaining terms that will be giving you the simplification. Clear? I hope the point is clear. Everybody?
Yes, sir.
Arnav?
Yes, sir.
अभी दिख रहा है क्या स्क्रीन? लिखा क्या बराबर?
Yes, sir.
Okay. Finished? Written down the last step. That is your final answer. Right? Okay. टेक द सेकेंड रीजन. अभी z+1 वाले के लिए अपन क्या करते हैं? इट इज टू बी एक्सप्रेस्ड इन द फॉर्म ऑफ u, right? Whenever such kind of region is given, Z plus 1 less than 2, that means u less than 2, u by 2 less than 1. Now I will be using the step where it is expressed in the product form. One of the factor is z plus 1 which is u, but u z plus 3 के लिए वो क्या हो जाएगा u plus 2, and then I will be having the term as 1 upon u into u plus 2. Clear? Kunal? वेदांत? ओम प्रताप सिंह? याद आया है इसके पहले वन ऑफ द प्रॉब्लम वाज हैविंग द रीजन एज mod of z minus 1. So appropriately looking at the factors, we have adjusted it with the help of u. Take that appropriate term outside, raise the binomial expansion, and then we simplify. Okay, so 1 लाने के लिए 2 को बाहर लेना पड़ेगा, तो u by 2 plus 1, that means 1 plus u by 2, 1 upon 2u outside, raise this to the numerator by power as minus 1, apply the binomial expansion, open the bracket, replace the value of u. मेरे को expansion u में नहीं चाहिए, that is for our convenience what we have done. We want the expansion for the region where it contains z plus 1 and it should converge, it should exist. Therefore, I take it as less than 1. So purposely our expansion, series expansion should contain the term as less than 1. Okay. Open the bracket, 1 by u, 1 upon 2u into this bracket, 1 by 2u into 1 is 1 by 2u, minus u cancel, 1 by 4 plus u एक reduce हो जाएगा, 4 2 जा 8, u by 8 minus 2 8 जा 16 in the denominator, u cube upon u will become u square. So appropriately this is written. पहला term लाएंगे constant वाला, remaining u wale terms, then u square, then u cube, but our answer should be written in the form of z. What is u? Z plus 1. So we replace the value for u as z plus 1. This is your final answer. Okay, so accordingly we have simplified and got the value for the series expansion. Clear? Any doubt? Any doubt? If you're sending messages, please speak, because I am not able to see. Only pop-ups are there. See, in the question I have mentioned 4 regions. In the solution I have taken first and second. So it is your job to simplify it for the third region and the fourth region. Homework समझ में आ गया? क्या practice करना है? यथार्थ शर्मा noted down the homework that third and fourth region you have to do for this particular example. Clear? Answer is okay. Any doubt or difficulty? Yes, I will share the presentation or the video link. Okay, then you can note down the question.
Okay,
Fine?
sir.
Yeah.
Yes, sir.
Oh, written down all. So this is the end of the topic, Taylor's and Lorentz series expansion, right? So last topic that is remaining is contour integration. So we will discuss in short about it. I would suggest or say that initial topic discussion I will do. Later on, I can share the notes with you. If any difficulty, we can discuss it tomorrow. It is prime responsibility for each and every student, or of every student that go through each and every example of part 1 of contour integration. I will at random ask any student to talk or discuss that particular example. Will it be okay? Because as per examination point of view, if you see these many topics, whatever we have covered as a whole, those are sufficient for you, right? The additional part, the last portion of this particular unit, it can be dealt in a self-study topic, or it can be dealt as a self-study topic, but still I will discuss initially so that you get a link or thread for that, and then you can move ahead for part 1. Similarly for part 2 I will talk, right? Will it be okay? Or if you,
Sir, please send a PDF of this topic.
yes, I will share the video link only. Today's lecture का जो भी recording होगा ना, वो पूरा send कर दूंगा मैं आपको, चलेगा? तो उसमें आपका सब डाउट भी क्लियर
Yes,
हो
sir.
जाएगा। ओके, अच्छा, तो कंटूर इंटीग्रेशन वाले का आपका क्या कहना है? आप कर पाओगे कि शाल ये 2 दिन में जो भी लेक्चर्स है उसमें अपन पूरा डिस्कस करें? यू एक्सपेक्ट फ्रॉम मी दैट टू डिस्कस इट एज अ होल, और इनिशियल पार्ट इनिशिएट करने के बाद यू विल सी ऑन योर ओन, वट एवर इज योर से। आई एम कंफर्टेबल विथ एनी। बोलिए, इसको बंद कर दूं?
सर आप वीडियो सेंड कर दो, वो देख लेंगे।
कौन सा? आगे वाले टॉपिक का?
यस सर।
ओके, ओके। Shall we end this particular topic?
सर कभी वीडियो नहीं समझा तो फिर एक्सप्लेन कर देना।
Yes, yes. I'll start. I'll not leave it on you completely. ठीक है?
यस सर।
ओके, फाइन। इसका अपन इनिशियल पोर्शन में बता ही देता हूँ ना, इतना नहीं आपके भरोसे रहूंगा। Yes, is the screen visible? Contour integration, integration around unit circle. Is it visible?
यस सर।
All are able
यस
to
सर।
see? Okay, fine, chalo. The last part of this particular unit is contour integration, which contains two types. One of them is integration around unit circle, and another one is integration around semicircle. Okay, so first part what we are going to talk about today is integration around unit circle. If you remember well, in Cauchy residue theorem, what third point we have written that उसमें क्या करना पड़ता है? We take the derivative of the denominator and then calculate the residue, and further we simplify by multiplying it by 2 pi I. What is the statement of Cauchy residue theorem? Integral over closed curve C f of z dz is equal to 2 pi I into sum of the residues at poles within C. I hope this is clear to everybody, the statement of Cauchy residue theorem. तो उसमें while calculation of residues, one of first formula or the step was calculation of residue for simple pole. Second point was calculation of residue for a pole of order R, and third point was general point, wherein if you remember साइड में अपन ने लिखा था कि मोस्टली इट विल बी यूज्ड इन कंटूर इंटीग्रेशन, और उसका एप्लीकेशन वाला एक प्रॉब्लम देखा था जिसमें वी हैव द न्यूमरेटर एज e टू द पावर z and denominator as cos hz, whose derivative was taken sin hz. So I would say, or I would suggest rather, that in problems of contour integration, may it be integration around unit circle or integration around semicircle, we usually focus on that particular third point of calculation of residue, where may it be any kind of pole, we will be only taking the derivative of the denominator and putting down. वो लिमिट वाला जो झंझट रहता है ना, वो अपन अवॉइड करेंगे, क्योंकि कभी कभार पोल्स जो है वो इजीली फैक्टराइजेशन से नहीं आएंगे।
सर साउंड इज नॉट क्लियर।
Is it not? Is it not? आवाज नहीं आ रहा था कि क्लियर? एनी इंटरप्शन? नॉर्मली क्लियर है मैक्सिमम स्टूडेंट्स के लिए? या अर्नव आपके वहां का इशू दिख रहा है मुझे राइट फ्रॉम द बिगिनिंग? क्लियर है ना? ओके 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 ओके. So, whatever is the third point of Cauchy residue theorem for the calculation of residue, we will be mostly focusing in, because whenever it is a simple pole, we have to apply the limits and then find out the answer. Or whenever it is a pole of order R, we have to simplify. So, general method is always to be taken appropriately, that whenever we have the whatever is the integrand, we calculate the residue by taking the derivative of the denominator if it lies within the given region. So in this case also, contour integration around unit circle. Now tell me, what is the interpretation of a unit circle? Unit circle यानी क्या होता है? Mod z is equal to 1. Unit circle means whose radius is 1. How that circle will be represented? That circle will be represented in the standard form as mod z is equal to 1. What does mod z represent? Mod z represent x square plus y square. So this equation becomes x square plus y square is equal to 1. What is interpretation of this x square plus y square? X square plus y square means it is a circle with center at origin, means 0 comma 0 and radius equal to 1. I hope this point is clear. So unit circle means a circle with center at origin and radius equal to 1. It is the standard equation. But up till now, whatever questions we were dealing, those were containing the variable as z. आपने जो भी इंटीग्रल देखा था वो इंटीग्रल ओवर क्लोज्ड कर्व सी क्या था? f of z dz था. अभी कंटूर इंटीग्रेशन अराउंड यूनिट सर्कल में आपके जो इंटीग्रल्स रहेंगे वो अराउंड क्लोज्ड कर्व सी नहीं दिए जाएंगे इनिशियली. दोज विल बी डेफिनाइट इंटीग्रल्स. Moreover, integrand में what term will be involved? Term of theta will be involved. But looking at the previous background of complex analysis, I do not have provision to simplify these integrals containing the definite integration as well as the terms of theta involved in them. So मैंने क्या करना है? ये क्वेश्चन को कन्वर्ट करना है z में by proper substitution and converting them around the unit circle for the closed curve C. Once that is done, I can apply the Cauchy residue theorem if the poles are lying inside the given region. अभी region is always fixed, it is unit circle. तो मेरे को ये चेक करना है कि whatever poles are generated, whether they are lying inside or outside. If I confirm that those poles are lying inside the given region, I can calculate the residue. Once calculation of residue is done, apply Cauchy residue theorem. So initial question will be in terms of theta. I have to convert it in the appropriate terms of z by proper substitution. वो कैसे करना है? We will see very soon. Right? The background is clear. So note down that the real definite integral of the type I is equal to integral from 0 to 2 pi. Now see, a unit circle, complete circle कब होता है? जब वो एक रोटेशन कंप्लीट करेगा. सो यहां से मैंने थीटा इज इक्वल टू 0 से स्टार्ट किया. वन रोटेशन इन एंटी क्लॉकवाइज डायरेक्शन कंप्लीट होके यहाँ पर फिर से क्या मिलता है मुझे? 2 पाई मिलता है. So rotation in anti-clockwise direction will generate a one complete circle when it is moved between 0 to 2 pi. So real definite integrals of the type I is equal to 0 to 2 pi f of cos theta comma sin theta d theta, where given integrand is a rational function. Rational means numerator upon denominator contains both variable or in terms of theta, mostly cos theta and sin theta, which can be solved by Cauchy residue theorem. सो लिखिए प्रॉपरली कि हाउ द इंटीग्रल विल बी, what will be the type of integrand, rational algebraic function in theta mostly containing cos theta sin theta. Limits of integration will be 0 to 2 pi, which represent one complete circle or a unit circle, which can be solved by Cauchy residue theorem. Abhi, just now I said that how it will be converted to z from theta. See, z is equal to r e to the power I theta is the Euler's formula conversion or polar formula for Cartesian coordinate system. How we generate this? Put x is equal to r cos theta, y is equal to r sin theta, r common, cos theta plus I sin theta is written as e to the power I theta. r यानी रेडियस कितना है, रेडियल स्ट्रिप का वैल्यू 1. सो क्या बनता है, सी इट, we get z is equal to r e to the power I theta, r is equal to 1 है तो z is equal to क्या मिलेगा, e to the power I theta. So for a unit circle mod z is equal to 1, z क्या मिलता है, e to the power I theta. मुझे f of z को भी कन्वर्ट करना है और dz को भी कन्वर्ट करना है, तो dz मैं लूंगा यानी डेरिवेटिव ऑफ z. So derivative of this z will be dz. Derivative of e to the power I theta is e to the power I theta into derivative of I theta. I constant, theta ka derivative with respect to theta is 1 and d theta will be written. So what is d theta? D theta is 1 upon iz dz. ये e to the power I theta नीचे चले जाएगा तो उसका वैल्यू क्या हो जाता है, z. So d theta will be dz upon I e to the power I theta. But what is e to the power I theta? Z. So d theta is 1 upon iz dz. क्लियर? ये कन्वर्जन हमेशा याद रखिएगा बिकॉज इट विल बी यूज्ड इन एवरी प्रॉब्लम. Clear? Noted down up to this how this came. So we will be converting theta d theta in terms of z. But I told you that integrand will contain rational algebraic function for cos theta and sin theta. So what will be the proper substitution for cos theta and sin theta, वो अपन ध्यान देंगे. यहां तक हो गया बेटा सभी का? Noted down properly. हाँ. So I becomes your complete integral over closed curve C f of z dz. मेरा जो थीटा वाला टर्म था पूरा मैंने कन्वर्ट कर दिया उसको f of z में. इंटीग्रल के जो लिमिट्स थे 0 to 2 pi, those are converted to or simply written as integral over closed curve C, where C is the region mod z equal to 1. So by Cauchy's residue theorem, this integral, original question is now integral over closed curve C f of z dz. उसको कैसे सिंप्लीफाई करना है, 2 pi I into sum of the residues of poles of f of z within C. So that is what the result will be or the solution will be for the given question of contour integration around unit circle. This will be the final answer by means of Cauchy residue theorem for the given question of contour integration around unit circle. Done up to this. Now I told you that we have to appropriately convert cos theta and sin theta also. D theta का तो conversion आ गया. This is the conversion for d theta which is 1 upon iz dz. Now cos theta और sin theta के लिए ये ऐसा आएगा. आप बोलोगे अभी ये कैसा? This is Euler's formula. क्या होता है बेटा? E to the power I theta is, what is e to the power I theta? कोई बता सकता है? What is e to the power I theta written as? E to the power I theta is cos theta plus I sin theta. What is e to the power minus I theta written as? क्या होगा ये? Cos theta minus I sin theta. So add करोगे दोनों को तो I sin theta cancel. 2 cos theta will be equal to e to the power I theta plus e to the power minus I theta. So cos theta becomes e to the power I theta plus e to the power minus I theta upon 2. But what is e to the power I theta? Z. What is e to the power minus I theta? Z to the power minus 1. Z to the power minus 1 यानी क्या होगा? 1 by z होगा. So this becomes z plus 1 by z, means z square plus 1 upon z. ये समझा क्या? Is it okay? Similarly, for sin theta you have to subtract them too. But वो I बचेगा, इसीलिए there the difference is 1 upon 2i, and here instead of plus it is subtraction. And that is how we have to simplify and get the substitution for cos theta and sin theta. Clear? Any difficulty? कुछ क्लैरिफिकेशन चाहिए? कुछ पूछना है? Is it understood well? So substitution for cos theta will be 1 by 2 z plus 1 by z. Substitution for sin theta will be 1 upon 2i z minus 1 by z. Substitution for d theta will be 1 upon iz dz. So every theta terms of theta are to be converted in form of z. तो वो बन जाएगा इंटीग्रैंड f of z dz. Now limits रहेगा जब 0 to 2 pi, then it can be taken as a unit circle, so that is converted to integral over closed curve C. ऐसा लिखते हैं ना अपन, integral over closed curve C. So whenever it will be limits 0 to 2 pi, it is applicable, or 0 to 2 pi limits represent unit circle. The region or boundary for unit circle is mod z equal to 1. Sometimes you may not be provided with the limits as 0 to 2 pi. Something different can be there. So by property of definite integration मुझे चेक करना है given function odd है, even है, और उसको कैसे सिंप्लीफाई किया जाएगा. क्लियर? तो वो शॉर्ट में अपन एक एग्जांपल के तौर पे देख लेते हैं. Written down. Shall we move?
Yes, sir.
Okay. Next question लिख लीजिए. Evaluate. Many times this is asked. 0 to pi d theta upon 3 plus 2 cos theta by contour integration. सी थीटा वाला एग्जाम्पल पे कुछ लिखा भी नहीं है, तो भी अपने को प्रोसेस कौन सा या मेथड अप्लाई करना है? कंटूर इंटीग्रेशन का ही अप्लाई करना है. ठीक है. सो मोस्ट ऑफ द टाइम्स दे राइट देयर कि बाय कंटूर इंटीग्रेशन, सॉल्व दिस बाय कंटूर इंटीग्रेशन. बट नहीं भी अगर लिखा रहा तो व्हाट वी डू, वी अप्लाई द कंटूर इंटीग्रेशन कंसेप्ट ओनली. क्लियर. सो बाय कंटूर इंटीग्रेशन, सो थीटा में है इसीलिए वी कन्वर्ट और ट्राई टू फिट दिस इनटू टाइप नंबर 1. what does type number 1 says? Contour integration where integration is around unit circle, but for unit circle what is the requirement of the limit? It should be 0 to 2 pi. Requirement of the limit is it should be 0 to 2 pi, but यहाँ पर क्या दिख रहा है? 0 to pi दिख रहा है. So my first job is to convert the limit of integration to 0 to 2 pi, then only it will be unit circle mod z is equal to 1. अभी what is the property of definite integration? एक property ये कहता है integral 0 to 2a can be splitted as 2 times 0 to a if it is even function. So 0 to 2 pi f of x dx will be 2 times 0 to pi f of x dx if it is even. So मेरे पास 0 to pi है तो ये 2 को मैं इधर लाके मल्टीप्लाई कर दूंगा एज 1/2. ये समझा क्या? The property of definite integration says that integral 0 to 2a is equal to 2 times 0 to a if the integrand is even function. So मेरा कहना है कि 0 to a क्या हो जाएगा? It will be half times 0 to 2a. So अभी लिमिट्स मेरे 2 टाइम से आ गए, वही मैंने करना है कि 0 टू पाई वाले लिमिट्स को कैसे लिखना है? 1/2 टाइम्स लिमिट 0 टू 2 पाई प्रोवाइडेड फंक्शन इज इवन. अभी इवन फंक्शन के लिए रूल क्या है? कांस्टेंट ऑलवेज इज एन इवन फंक्शन. cos theta is also even function. How we determine whether the function is even or odd? Replace the theta by minus theta. If you are getting the original term, you say that function is even. If the term is minus times the original function, you say the function is odd function. So in this integrand constant term 3 जो है वो even है, cos theta is also even. So as a whole ये अपना इंटीग्रेंड कैसा फंक्शन है? even. even फंक्शन के लिए ये प्रॉपर्टी मैं अप्लाई कर सकता हूं. तो मेरा क्वेश्चन जो 0 टू पाई डी थीटा अपॉन 3 प्लस 2 कॉस थीटा है वो कैसे हो जाएगा? हाफ टाइम्स इंटीग्रल 0 टू 2 पाई d theta upon 3 plus 2 cos theta. Now this original question is converted to proper limits. So I can say that there is a unit circle or the region is unit circle mod z equal to 1. So original question I is converted to half multiplied by whole integral. तो आखिरी में जो भी आंसर आएगा उसको किससे मल्टीप्लाई करना पड़ेगा? हाफ से. Because now I will be focusing on this integrand as f of z over closed curve C by substitution of d theta as well as by substitution of cos theta. Done? Clear up to this? बोलिए बेटा फटाफट जल्दी.
Yes, sir.
Now mod z equal to 1 unit circle, z is equal to e to the power I theta, dz is equal to e to the power I theta into I into d theta. So क्या बन जाता है? d theta is 1 upon iz dz. cos theta के लिए half of z plus 1 by z. This is the substitution. Clear? Noted down up to this. Any doubt? सो अपना क्वेश्चन अभी किसमें कन्वर्ट होगा? हाफ एज इट इज इंटीग्रल 0 टू 2 पाई विल बी इंटीग्रल क्लोज्ड कर्व C 1 अपॉन 3 प्लस 2 cos थीटा 2 into क्या होगा, half into z plus 1 by z. So 2 get cancel, it becomes z square plus 1 upon z, and d theta is replaced as 1 upon iz dz. Take LCM here, so it becomes 3z plus z square plus 1 upon z into 1 upon iz. Out of that I have taken I outside, तो क्या बन गया, 1 upon 2i. This z will go to the numerator, पर ये z और ये z कैंसल हो जाएगा. सो क्या बचता है आखिरी में, dz अपॉन 1 upon 2i इंटीग्रल ओवर क्लोज कर्व सी dz अपॉन z स्क्वायर प्लस 3z प्लस 1. ओके, एलसीएम लेना है, सिंप्लीफाई एंड गेट द आंसर. नाउ दिस टर्म इज नॉट फैक्टराइजेबल. मेरे को जो रूट्स निकालना है वो फैक्टराइजेबल नहीं रहेंगी. ठीक है, ऐसे फैक्टर्स नहीं आएंगे. बट अपन क्या करेंगे, उसको यूनिट सर्कल में पॉइंट्स लाए होते हैं कि नहीं देखना है मुझे. इक्वेट दैट डिनोमिनेटर टू 0. कैलकुलेटर पर से आप निकाल सकते हो. व्हाट विल बी द रूट्स फॉर दीज. फाइन. 1 upon z square plus 3z. Poles of f of z. Call this as f of z. Poles of f of z will be equating the denominator to 0. इसको सॉल्व करोगे फॉर्मूला मेथड या डायरेक्टली कैलकुलेटर पर से, माइनस बी प्लस माइनस अंडर रूट ऑफ बी स्क्वायर माइनस 4ac अपॉन ट्वाइस ए. So one of the root is minus 3 plus root 5 upon 2. Another root is minus 3 minus root 5 upon 2. Root 5 is approximately 2.23. Now tell me, माइनस माइनस क्या होता है, प्लस, एंड साइन ऑफ नेगेटिव, यानी ये वाला जो नंबर है ये एडिशन होगा विथ नेगेटिव साइन, यानी ग्रेटर रहेगा. ये प्लस माइनस क्या होगा, माइनस. सो हायर साइन विल बी माइनस बट इट विल बी लेस देन 1. नहीं विश्वास है तो कैलकुलेट करके देख सकते हो. दिस वैल्यू विल बी लेस देन 1. लेस देन 1 क्यों बोल रहा हूं, क्योंकि रीजन या बाउंड्री क्या है, यूनिट सर्कल. तो ये कोऑर्डिनेट विल लाई इनसाइड, this coordinate will lie outside. So calculation of pole is always done for the calculation of residue is done for the pole which lies inside or on the boundary. So I will calculate only for this pole. अरे ये बात क्लियर हुई क्या?
Yes, sir.
Okay. Next, simple pole z is equal to minus 3 plus root 5 upon 2 lies inside the circle. So this lies outside. I told you that अपन limit वाला फंडा नहीं use करेंगे. What I will do, I will just differentiate this denominator and put the value. So simple pole z is equal to minus 3 plus root 5 upon 2 is given by 1 upon z square plus 3z plus 1 का derivative is 2z plus 3. Put z is equal to this value. Third point of the residue, derivative of the denominator. इतना कर लीजिए बेटा. Clear? So 2 कैंसल हो जाएगा, माइनस 3 प्लस रूट 5 प्लस 3 भी कैंसल हो गया, तो आंसर कितना बचेगा, 1 अपॉन रूट 5. दिस इज रेसिड्यू. इसको 2 पाई आई से मल्टीप्लाई करना है, और आखिरी में आई ओरिजिनल इंटीग्रल आई इज इक्वल टू हाफ टाइम्स ये था. So that is how by Cauchy residue theorem 2 pi I into sum of the residues at poles within C 2 pi I into 1 upon root 5, 2 pi I upon root 5 is the value for only this integral. But original question में half multiplied by this integral था. So that will be giving you the answer. Half नहीं, 1 upon 2i. multiplied by this. I also we have taken outside, no, d theta ka jo 1 upon iz dz tha, so that is also taken outside, so it becomes
सर थोड़ा ऊपर का दिखाएंगे.
हाँ wait. Is it written? Okay. रिगार्डिंग रेसिड्यू लिख लिया है. सो 2 मल्टीप्लाइड बाई ये ऐसा होगा, प्लस 3. सो 2 cancel, -3 plus √5 plus 3 is only the remaining term. So by Cauchy residue theorem, this is 2 pi I into sum of the residues at poles within C. This value is 2 pi I upon √5. Original I में 1 upon 2i multiplied by this integral जिसका value ये निकला है. So final answer I get it as pi upon √5.
हो गया.
Okay. So this is your original question. 1 by 2 क्यों आया था? Because we changed the limits to 0 to 2 pi. Because original question contained 0 to pi, and for me, for a unit circle, limit should be 0 to 2 pi. So final answer is pi upon √5. Clear? Everything is okay?